Project 3.3.2, CHUMP, Program EEPROM. So here's a pinout diagram of the AT20C16 EEPROM chip. So basically, the VCC and the ground should be connected to power and ground respectively. And then for the address pins right here that I've outlined, they control which address the EEPROM chip is at. So by using this equation, there's 11 address pins, so 2 to the 11th means that there are 2048 addresses in the EEPROM. Here is the input-output pins. So basically there are 8 input-output pins, and we can use this to determine how many bits there are in the EEPROM chip, which is 16K. In order to write into the EEPROM, you need to turn this output enable high, and then you also need to turn this write enable high. And then after you set the addresses and the output and input pins, whether that is by nano or by manual wiring, you turn on this write enable pin by pulling it low for 1 microsecond and then pull it back high again. And this is how you burn into the EEPROM. And to output things from the EEPROM, the output enable pin needs to be pulled low, and then the input output pins here will display whatever was burned into the EEPROM for the specific address it was at. And this chip enable pin needs to be pulled low in order for the chip to do stuff.
So this is my EEPROM burner, and all the I/O pins on the EEPROM are connected to pins on the nano, as well as the write enable and the output enable pins, and also 4 address pins. And 3 more addresses are connected to these 3 switches right here, so I can burn like more 16 bytes of code for different variations. So to burn this EEPROM, I need to use this code right here. So basically what that does is it sets the data on the I/O pins and also the addresses, and by pulling the write enable low for 1 microsecond and then pulling it high again, I will burn the code into the EEPROM and set it. So if I just upload this code right here, as you can see, it went from counting from 0 to F to displaying this is the Feinberg's lower nibble code. So here I've got the EEPROM chip controlling a dual 7-segment display right here. So from the previous circuit, the 4 outputs go into the 4 addresses of the EEPROM. So when I turn on this, it starts counting through the addresses, and then it's displaying what the machine code that I wrote for the last project in hex. And if I turn on this switch, that is Feinberg's program in hex. There it is. And then if I turn on this switch, that is it in the machine code. And here, if I do this, this is Feinberg's program in machine code. Okay, so how I use one EEPROM to control both of these is using a Civil 555 right here. One of them goes to the common cathode of one of the displays, and then the other one goes to the inverter, and then goes to the other common cathode of the display. So that will make it so that these will have persistent emission, and that causes both of them to appear to be on at the same time, but they're not. And also this 555 is also connected to one of the addresses on the EEPROM, so that they will have different things sometimes. For example, when I switch to this, like, they will have different numbers. So here I've got my circuit here with the code that I wrote for the last project. So as you can see here, the machine language instructions, and here is the dual segment displays right here. So I've wired the displays from A to G, and then the decimal point as like A is this one, and then G is this one, and then this one's the decimal point. So as you can see right here, only A should be on because only the first bit should be on, which is correct. If I just step through this, you can see that every one of these is in fact matching what the machine language instruction says on here. And then here I have the Feinberg code down here, and if I turn on the Feinberg here, this is matching what the Feinberg code is saying through 05, and yep.